So we got a board game designer, right?
Yeah.
And you're on Google's internationalization team. Excellent.
right.
And a guru on Unicode and TC39. And all of the rest I will leave to you. Thank you. And looking forward to your presentation. Thanks, Shane.
Give it up for Shane.
All right. You can all hear me? Great. My name's Shane. Thank you for the introduction. I work on Google's internationalization team. I also sit on TC39, which is the JavaScript standards body, as well as the Unicode ICU4X TC, which I'll show you about a little bit later. So I'm going to be talking to you a lot today about this big long word here. It's internationalization. It's I followed by 18 letters followed by N. As programmers, we like to abbreviate things and make them shorter. So this is I-18N. In fact, it's one of the longest words in the English language. So we like to abbreviate that as I-18N. So what is I-18N? These are screenshots from YouTube, this YouTube video. On the left here, I have my locale set to Japanese. On the right, I have it set to Spanish. And we can see a little bit about what changes when you change the language of your web browser. So on the right here, for example, you can see that there's, obviously the translations are in the appropriate language, but you can also see things like on the right, you have a bit more than 1 million upvotes on this video. On the left, I have 191 something. I have 191 wands, actually, which is 10,000s because groupings work differently in Japanese, for example, than in Spanish. Obviously, dates change. Many different things change when you change your locale. So there's a whole lot of things that can change when you go to different languages. This is just a sample of some of the things that you might need an internationalization library to solve. Things like locales, numbers, currencies, units, dates, times, time zones, numbers, date ranges, relative time formats, temporals, eras, collations, plural rules, list formats, language display names, region display names, text segmentation, and the list goes on. And all these things change when you change your language, when you change your region. Somehow, software needs to figure out how you can operate your application correctly in a certain language. So, a lot of people sometimes tell me, like, oh, well, that's all great and all, but like, I-10 is a solved problem, right? Like, this is one of many other jokes you can tell yourself, because this is one of the biggest myths that sometimes I hear. Languages change, regions change, time zones change. And we try to keep up with the latest and greatest things that you can do with languages. So a lot of this comes down to having an internationalization library that can solve these problems for you. So we have goals in developing an internationalization library that you can then plug into your app and have it work in many of these different languages and many of these different regions and locales. One of the things that you would want from internationalization library is you want to pay for what you use. You want to be able to have add extra locales on demand. These two things sort of go hand in hand. On the bottom left here, I've got a little graph that shows the common locale data repository data size. There's hundreds and hundreds of locales supported, and each of those locales has many features in it, and the number of features, when you take number of features, from the previous slide, you saw the list of features, you multiply that by the number of locales, you get like a quadratic explosion of data. So you have a lot of data. You only want to ship what you need. The next thing you want to do by adding extra locales on demand is to be able to maybe download extra locales, load them into your application, but depending on what language the user speaks, it doesn't make a lot of sense to ship 300 languages if the user speaks maybe 5. Right? So you want to be able to load extra locales on demand. You want to be able to run in resource-constrained environments. You want to be able to run on anything from a microcontroller to a data center, right? And you want to be able to keep up with the latest and greatest programming languages. We want to be able to write once, and we want to be able to have it work anywhere, in this case, programming languages. Internationalization sits at the border between programming languages and human languages, right? So we want to be able to write once and run anywhere. So this is when Unicode decided to form the ICU4X Technical Committee. The ICU4X Technical Committee is one of the things that I'm a part of. It's a cooperation between several organizations that you may have heard of in order to develop a new library in order to solve all of the problems that I had on the previous slide, problems that the existing libraries written in C and Java didn't really solve for us. So this is when we decided to go ahead and form the ICU4X project. So this is a little timeline of the history of the ICU4X project up to now. In 2019 is when we sort of, formulated these ideas, pitched the ideas, see if we can get a team together and to start solving the ideas. In 2020, we made one of the most pivotal decisions, which is obviously to go with Rust for solving these problems. We implemented some of our early infrastructure. A couple years later, in 2022, we released the 1.0 version of ICU4X, the ICU4X Rust project. In 2023, we started landing on some of our clients. We landed in the Firefox web browser and the Pixel Watch, among others. And then 2025, just last week, we released the ICU4X 2.0 release. We also landed in Android, and we're working on other clients. This also means that it's our 5th birthday, so that's always exciting. From the 0.1 to the 2.0 release, it's our 5th birthday. So that's exciting. So here's some examples of some clients that would use ICU4X, like who use the things that we built. On the left, we've got CanvasKit, which which can use us via WebAssembly. In the previous talk, you heard a little bit about Skia. So this is basically Skia on the left side. All these components fit together when you do like text rendering. It's really mind-boggling how many things you need in your text rendering stack. And internationalization, in this case, text segmentation is one of them. We're on the Pixel Watch. If you happen to have a Pixel Watch in ambient mode, ICU4X is what's rendering your times and dates and heart rates and things like that. On the right side, we run in data centers. We help reduce and make more efficient internationalization in data centers as well. It's kind of mind-boggling the scale that when you have a core library that gets like half as big as the previous one, then you can save a mind-boggling amount of like compute resources. These are more ICU4X clients. If you use Firefox, you're already using us in your text segmentation, as well as in the temporal datetime library that's coming soon. The Rust C compiler uses ICU4X for error messages, for certain parts of error messages. Android, as I just mentioned a little bit earlier, we've got for Unicode properties, and Chrome is a work in progress. We have some changeless open that will hopefully be landing quite soon to do things like transliteration and temporal. A lot of people have put a lot of time into making all these things happen, so this is quite exciting. Okay, so now let's talk a little bit about like what is the library. It is IE10N, that is portable, lightweight, and secure. So let's talk about all those words and what they all mean. So on the top left here, I was afraid it would be too small, but this is such a big screen. You can actually see everything on the screen, which is quite cool. On the top left shows the performance. This is just like, this is just a criteria and benchmark. This is, how fast can you render the date and time, right? So on the top left, we've got, on the far left, we have the ICU4C, which is the C++ code. And on the far right, we have the ICU4X 2.0 Rust code, which is quite a bit faster. And this is, I'm really happy that we're able to achieve this. The other columns are different configurations for ICU4X depending on what version you're using. But the one on the far right is the one that you'll probably be using if you just install it from crates.io. On the top right, we show the memory usage. This is also, I think, something I'm really proud of. Like, basically everything that we do with formatting of datetimes and everything that you can do with internationalization library, we do without allocating any memory, which means that implies that we have very low memory usage. So that's what you can see on the right here. This is a logarithmic scale because basically I think we have like one allocation or something in like datetime, which is like, allocating like the string to render the output or something like that. And that's what's probably showing up in these benchmarks here. But very low memory usage. It also means that we can run in no-stud environments at places where you don't have an allocator. ICU4X solves that problem for you. On the bottom left, we can show that we already have very good binary size. So this is like if you build your app and you want to reduce the size of your APK, for example. A lot of people care about that. We're improving even upon the benchmarks we've already set for ourselves. We cut in half, even since ICU4X 1.5 to the 2.0 release, the binary size. And this is the code size versus ICU4C and ICU4X. This is a linear scale. This is comparing apples and apples. I tried really hard. I'm also a contributor to ICU4C, and I tried really hard to make sure that I was comparing apples to apples as much as I could. And This is I think the bottom right graph I think is the graph that I really want to emphasize. A lot of people are like, why didn't you just can we get the same results from ICU4C? And we really needed to start with a clean slate in order to achieve these results, and that's what we did. So I'm at Rust Week, right? People are like, that's great. Like, why did you choose Rust to solve your problem? Tell us more. So no other programming language was going to be able to do everything that we needed as well as Rust. So Rust works on all different types of devices. It's good for high performance and low memory environments. It does Unicode string handling by default for us, which helps us, which means that we don't have to ship expensive character encoding pieces of our stack. We have tree shaking, LLVM integration, helps us achieve small code size. It works really well with foreign functional interface, cross-language portability. It supports zero-copy deserialization. And one thing that I really didn't appreciate until after I had used it for a while is that it's really good for tooling and productivity. We have a large network of contributors, and Rust really helps us be able to review the code and land code and know that it's going to be safe and going to be secure. So that's really important. So let's talk a little bit about how ICU4X achieves its small binary size. So we optimize for dead code elimination. I'm going to go through this slide a little bit fast because I'm running a little bit low on time. But we focus on functions with a single purpose. We have data linked into each individual function. We have careful use of generics. Generics can either make your code big or small, depending on how you use them effectively. We reduce code bloat. I already talked about allocations. We impl copy when possible. This is something people are interested in sometimes. All of our error types don't have a drop impl, and this actually does a big job of reducing your code size. And another is we avoid linking debug impls when possible. Debug impls often increase your code size. These are just general tips on how to reduce your code size, but these are the things that really have given us the most results for ICU4X. Zero copy deserialization. I'm going to talk about that in the next slide. I'm probably going to go through this slide fairly quickly, but this is a very important slide, so I'll try to spend a little bit of time here. The ICU locale crate, which does locale canonicalization and so forth, has many dependencies. But the reason we have many dependencies is because we really focus on making our code modular and pulling out the pieces that really enable us to achieve these goals. So on the orange boxes are like the ICU4X core crates. These green boxes are things that we've then contributed to the Rust ecosystem, right? So these are all things that you can use in your own apps. The title of this talk is Beyond ICU4X, so I'll talk a little bit more about a couple of these. But tiny string lets you have tiny strings in the stack. Writable is fast string formatting. It's almost twice as fast as the standard library display trait. We've got databake, which databake, Zervac, and Yoke I have slides about right after this one. And then we also use some standard library, or not standard, sorry, we use other ecosystem traits that we leverage. So it's a lot of crates. People, when they install ICU4X, like, oh my God, so many crates. It's such a big library, but it's a big giant library. I just showed you the graphs a few slides ago. It's actually quite small and compact. So all these things are zero-cost abstractions. Again, the thing that we can do with Rust that's very hard to do in other languages, these zero-cost abstractions give us these small binary size even if you see a lot of crates coming in. Zerovec is one of the util crates that we have. It's a way that we can take a vector of strings or integers or whatever and pack it into a binary format that we can then do zero-copy deserialization for. So this is a little example of how Zerovec can work. If you're in any situation where you need to do low-cost deserialization, Zerovec is a really good tool for that. Yoke is a tool that we use to solve self-references, and we solve that by having, for example, if you have a data file that you've loaded and you have a lot of locale data in that data file, maybe you loaded a new language pack, for example, you want to have a lot of things reference your language pack. What we do here with lifetime erasure, basically, is by having your deserialized data borrow from your buffer, and then we have many yokes that can then have reference counts to the same buffer, and you don't have to carry lifetimes around everywhere because oftentimes you want to create your formatter and you don't want to have a lifetime borrowing from some data file somewhere. This is how we can achieve that with Rust. Another exciting one is databake. This is a thing people are like, how does this work? How can you achieve optimal binary size and data size? Well, you can actually serialize your data as Rust code, right? So for example, if I have a data structure that has a string and an integer in it, we can generate Rust code. And we've serialized your REST code, but we've serialized your data, but we've serialized it as Rust code. We didn't serialize it as JSON, we serialized it as Rust code, because why not? It's something we can do in Rust. Just a few more slides here. Diplomat is another thing that people are very excited about. It's how we scale to many different programming languages in terms of the number of languages. So the motivation here is that we want to support many programming languages, C++, Dart, JavaScript, etc. We do it via the C ABI, which is the lingua franca. I'll go through this slide fairly quickly. C bindgen, WASM bindgen are great tools, but they target one language at a time. How can we target many languages all at the same time? By using the Diplomat macro. It takes Rust code and transforms it into something that you can use in many different programming languages. Here's a little example of how that works, the Diplomat macro. So on the left, you've got your Rust code. On the right, we have the corresponding C ABI. The C ABI calls back to the Rust code, and you can then run this in many different programming languages. One thing I want to emphasize here is that it's very easy to add another programming language. We've had contributors from many different places and backgrounds contribute. These are some of the contributors on the bottom here, and the language that they've spent the most time contributing. And this is a great way to contribute, which actually leads me to my last slide. I don't have time for telling you what's new in ICU4X 2.0. You can just read it here. You can also read the email that I sent out last week for more information here. So that was a lot of material. Watch this talk again if I went through it too fast or you want to learn more. There's also other talks you can find about other specific topics. And this is my conclusion slide. So I told you about how you can be a contributor, contributing to Diplomat, contributing another programming language. That's a really great way to get involved. We have a lot of mentorship opportunities. We have a lot of features that need to be implemented still, because internationalization is a very big space. There's a lot of things we could implement. We have a lot of open issues. We have a lot of good first issues. You can get in contact with me or anyone else from the team. And please use our infrastructure. Our infrastructure is here. It works. It's standalone. Even if you're not doing internationalization, maybe you need zero-copy deserialization. Maybe you need Databake. Maybe you need one of these other tools, Diplomat. If you want to take your Rust library and use it in some other programming language, Diplomat's also there for you. So, the point of this talk is really to, drive home these points, show you some of the things that we've done, contributed back to the ecosystem, and we're a very big open project. So that's my last slide. So I think we have time for a couple of questions. Thank you.
Thank you, Shane. We should have given you a longer time slot. There was a lot of talk in there. That was amazing. All right, are there any questions? Here, and there's a catch box over there. Great form.
Does it work? Holy shit. It's amazing. Okay, so in the example ICU4X clients slide, you showed a canvas kit with some text and that you were resizing the canvas kit. I'm curious, did that was that actually doing text segmentation or was it not for like the line wrapping? Because
yeah, I'm scrolling back to this slide. Here's the slide you were talking about. Yeah, so it's using ICU4X for the text segmentation is what's going on here. So it has to figure out when and where to break the words. This is it's in a language that has spaces to separate. It's like you just look for the spaces. But I think on one of these slides, maybe the previous one up back here, I have examples of, for example, there's a Japanese text on the bottom right. There are no spaces. You have to figure out where the word breaks are, right? And this is the thing where we have to have an internationalization library to solve that problem.
Exactly. Nice. Okay. Amazing.
All right.
There's a question there all the way in the back. Yeah. Oh, this is going to be a big throw. This is fun. You're going to do it?
Do it.
Yeah.
All right, it should get a little bit of an extra boost.
Yeah.
There we go.
Almost.
Hey.
Here we go.
With Diplomat, you put the derive macro only on the struct definition. So how do you get the list of methods in the import block?
Diplomat macro, let me go to that slide. This slide here, I believe.
Yes.
The Diplomat macro goes on the everything on the left has is actually inside a module that has a annotation called Diplomat Bridge, which is not actually shown on this slide, and it should be. But all the code on the left is analyzed by the Diplomat macro.
Okay, so it's the same thing CXX does.
It analyzes the whole macro and then generates the C bindings from everything that it analyzes. And it produces an HIR representation, which is what the target languages can use to then generate like the code that they use and then call into the C API bindings.
Cool, thanks.
There's a question over here on the right. Yeah, you can throw it back.
Ooh. In the meantime, I'll say that we are going into lunchtime, so if you really want to have lunch, then you could, but I mean,
I'll be around all week. Find me and ask me more questions.
Let's do a couple more questions. Go ahead.
Hey, thanks for the talk. It was great. I truly apologize for the following question, which is sort of beside the point of this whole thing. But you did pique my curiosity with the implementing copy trait to reduce the size of the binary. Are you saying that implementing the copy trait sort of forced you into a coding style that is more amenable to small binaries, or is it that having the copy trait implemented on, trivial structs actually changed the way that the code is compiled?
Well, I think the answer to this question is before we had the policy of implementing the copy trait for all of our error types, it was somewhat common to find things like a box dying error inside of error types, or to have a string inside of error types, a capital S string, and those things just really increase the size of the code because now you have a drop impl. Whenever you call a function, you have to have a drop impl for this error type, right? So enforcing this policy that all error types are copy has sort of focused us in the direction of being able to produce this small code size. Whether or not if you have the exact same structs or the exact same array enums, whether or not they actually have the copy attribute, the copy derive on them, I haven't actually tested to see if that has an impact on the code size.
All right. Just real quick, for the people who are walking out and want to have lunch, if you have any allergies, make sure that you talk to the people at the bar closest to the entrance.
They can hook you up.
They can direct you to food that is appropriate for you. But please carry on with the questions.
Last question.
Yeah. So one philosophical question: what can you do to increase adoption of this? One of the first slides you showed, people think that get text or strf time is the best thing ever. And how can you convince people that there is better ways?
One way is by coming to places like this, to Rust Week, to sort of emphasize it's really important to have your software support multiple languages as well. Raise your hand in here if you speak more than one language. This is a very easy question in the Netherlands, right? So people here understand this, even more than sometimes the other audiences that I give this talk to. But being able to build software that actually works really well across programming languages, it gives your apps a competitive advantage. If people like to use apps that work and make sense to them, I think a lot of experiences of multilingual users is well, I'll just switch to English because it's better in English. But that's not the world we want. We want a world where all 2,000 languages have really good experiences. And in order to produce that world, in Unicode, we're producing not only the ICU4X library, we also produce the Unicode standard. We're encoding new scripts. We work a lot with digitally disadvantaged languages in order to acquire data, in order to really build software that works for users in every country around the world, right? So, I think evangelization and really setting a good example is a really big step in order to produce the world that we're all striving for.
I think that's a fantastic closing answer.
I love the phrase, what was it, digitally disadvantaged?
Yeah.
That's a good phrase, I love it. All right, thank you so much.